When you picture a guillotine, you see the blade, the wooden frame, the basket below. But there's something most people never think about. How exactly did the blade fall? Who pulled what? And more importantly, why was the release mechanism designed the way it was? The guillotine wasn't just a frame with a falling blade. It was a carefully engineered device, and at its heart was a release system that most witnesses never understood. They saw the executioner move, heard a sound, and then the blade dropped. But the actual mechanism remained hidden, deliberate, and surprisingly sophisticated. This wasn't an accident. The people who designed the guillotine in the 1790s weren't just building a killing machine. They were solving a problem that had plagued executions for centuries: inconsistency. Axes missed, swords bent, executioners hesitated. The guillotine was meant to eliminate all of that, to turn death into something predictable, mechanical, and above all, controlled. But control required precision. And precision required a mechanism that could hold a blade weighing over 40 kilograms, keep it suspended at a height of nearly 3 meters, and release it in a fraction of a second without jamming, without delay, without giving the condemned person time to move or the crowd time to interfere. The release mechanism was the key to all of this. It was hidden from view, operated from a specific position, and designed so that even if the executioner hesitated, even if his hands shook, the blade would still fall exactly as intended. This wasn't cruelty. It was engineering. And understanding how it worked reveals something fundamental about how the French Revolution approached death, order, and the role of the state in taking a life. So how did it actually work? Let's start at the beginning. The guillotine was introduced in France in 1792 during the early years of the Revolution. Before that, execution methods varied wildly depending on your social class. Nobles were beheaded with a sword, a theoretically quick death if the executioner was skilled. Commoners were hanged, a slow and often botched process. The poorest criminals might be broken on the wheel, their limbs shattered before death finally came. Dr. Joseph Ignace Guillotine, a physician and member of the National Assembly, argued for something different. He wanted a single method of execution that would apply to everyone equally, regardless of rank. More importantly, he wanted it to be humane, or at least as humane as state-sanctioned death could be. Quick, certain, and painless. The design work fell to Antoine Louis, a surgeon, and Tobias Schmidt, a German harpsichord maker turned engineer. They studied previous beheading machines from Italy and Scotland, refined the blade angle, adjusted the weight, and built the frame. But the most critical challenge was the release system. Think about what they needed. A mechanism that could be triggered from several feet away, that wouldn't accidentally release, that couldn't be sabotaged easily, and that would work reliably even after hundreds of uses. Remember, this machine would be used in public squares, often in chaotic conditions, surrounded by crowds that might be hostile or overly enthusiastic. The executioner couldn't be standing directly under the blade. He needed distance and protection. The mechanism couldn't be visible to the crowd, because mystery added to the machine's psychological impact. And it absolutely could not fail, because a failed execution would undermine the entire purpose, to show that the revolutionary state was efficient, rational, and in complete control. The solution they developed was elegant, hidden, and surprisingly simple. But to understand it, you need to know exactly how the blade was held in place. At the top of the guillotine, there was a component called the mouton, literally sheep in French, though the origin of this name remains unclear. The mouton was a heavy metal weight, often around 40 kilograms, with the blade attached to its bottom edge. The entire assembly slid up and down between two tall wooden uprights called montants. But here's what most people miss. The mouton didn't just sit at the top, held by a simple rope or hook. It was secured by a wooden wedge called a déclic, or sometimes referred to as the déclenche. This wedge passed horizontally through a slot in the mouton, preventing it from falling. Look closely at historical diagrams and you'll notice something odd. The wedge wasn't held in place by a lock or a pin. It was held by tension, friction, and a rope. One end of the rope was attached to the wedge. The other end ran down through a system of pulleys to the side or back of the scaffold where the executioner stood. This is the key detail. The mechanism was designed so that pulling the rope didn't directly yank the wedge out. Instead, it released tension in a specific way that allowed the wedge to slide free smoothly. This prevented jerking, which could cause the blade to twist or catch in the grooves as it fell. The wedge itself was tapered, wider on one end than the other. When inserted, it locked the mouton firmly. When the rope was pulled, the wedge slid out in a controlled manner, and gravity did the rest. Why does this matter? Because this design meant that the executioner's action was reduced to a single, simple motion: pulling a rope. No strength required, no aim needed, no hesitation possible once the pull began. The machine did everything else. The release mechanism solved several engineering problems simultaneously. First, it had to hold significant weight without slipping. 40 kilograms of iron blade and mouton, suspended 3 meters in the air, created enormous downward force. A simple hook would bend. A rope alone would fray. The wooden wedge distributed this force across a broader surface area, preventing failure. Second, the mechanism had to release instantly and completely. If the wedge caught halfway out, the mouton might drop unevenly, causing the blade to strike at an angle. This could result in an incomplete cut, which would be both horrific for the condemned and humiliating for the state. The tapered design ensured that once the wedge began moving, friction decreased progressively until it slid free entirely. Third, the system had to be foolproof. The executioner might be nervous, inexperienced, or drunk. Revolutionary authorities couldn't afford botched executions, especially when executing prominent figures in front of thousands of witnesses. By making the action mechanical, they removed human error from the equation. Pull the rope, the wedge comes out, the blade falls, every time. The rope system also provided distance. Early designs had the executioner standing very close to the machine, sometimes even on the scaffold platform itself. Later, refinements moved the release point further back, sometimes behind a partial barrier. This protected the executioner from potential attacks by sympathizers in the crowd and also hid the exact moment of triggering, maintaining the machine's mystique. The pulley system allowed for mechanical advantage as well. The executioner didn't need to pull hard, just steadily. Some accounts mention a small wooden handle or crossbar attached to the rope's end, making it easier to grip. The entire action could be completed in less than 2 seconds from the decision to pull to the blade's release. Physics did the rest. Gravity accelerated the 40-kilogram mouton to approximately 7 meters per second by the time it reached the bottom. The hidden release mechanism wasn't just functional engineering, it was political theater. Public executions under the Revolution served multiple purposes: punishment, deterrence, and demonstration of state power. The guillotine's design supported all three. By concealing how the blade was released, authorities maintained an aura of inevitability. The condemned person couldn't see exactly when the executioner would pull the rope. They couldn't brace themselves or make a last gesture of defiance at the precise moment. The crowd, too, remained uncertain. One moment the executioner stood at his position, the next moment the blade fell. The gap between decision and death collapsed to nearly nothing. This created a specific psychological effect. Unlike a hanging where the condemned climbed stairs and the crowd could anticipate the drop, or a beheading by sword, where the executioner raised his weapon visibly, the guillotine offered no warning. The machine appeared to act on its own, as if death came from the device itself rather than from human choice. This was intentional. Revolutionary ideology emphasized law and rationality over personal power. The executioner was called Monsieur de Paris, a formal title that distanced him from the act. He wore a dark coat, not a hood or costume. He operated a machine. He didn't wield a weapon. The mechanism itself reinforced this. He pulled a rope, a simple, clean, administrative action. The machine did the killing. For the crowd, this created a paradox. They came to witness an execution, a deeply human ritual of justice and vengeance, but what they saw looked like an industrial process. The condemned was positioned. The lunette closed around their neck, and then, with minimal ceremony, the blade fell. Fast, efficient, impersonal. The hidden mechanism was central to this effect. It made the executioner less visible, the state more present, and death itself appeared to be a matter of procedure rather than passion. One common myth suggests the executioner used a lever that he pushed forward or pulled back, like a train switch. This isn't accurate. While some later guillotine designs experimented with lever releases, the standard French Revolutionary model used a rope and wedge system. The confusion likely comes from dramatic illustrations and film depictions that added levers for visual clarity. Another misconception is that there was a safety lock that had to be released first, requiring 2 separate actions. In reality, the mechanism was designed to be single action. Once you pulled the rope, the wedge came out and the blade fell. There was no intermediate step, no moment to reconsider. This was deliberate. Hesitation was the enemy of efficiency. Some accounts claim the executioner had to pull with significant force, straining against the weight of the suspended mouton. This exaggerates the difficulty. The wedge wasn't supporting the mouton's weight directly in a way that resisted the rope pull. Instead, it was inserted perpendicular to the direction of force. Pulling the rope slid it out horizontally, which required surprisingly little effort, perhaps equivalent to lifting 5 kilograms rather than 40. There's also a persistent story that the mechanism sometimes jammed, requiring the executioner to climb up and free the wedge manually. While mechanical failures did occasionally occur, they usually involved the blade catching in the grooves of the uprights, not the release mechanism itself. The wedge system was remarkably reliable. The weak points were elsewhere in the machine. Finally, some believe the rope was cut rather than pulled, severing it to drop the blade. This would make the machine unusable for subsequent executions without re-rigging. The rope was meant to be pulled free and reused, pulled back through the pulleys to reset the mechanism after each use. Understanding what the mechanism wasn't helps clarify what it actually was: simple, reliable, and disturbingly efficient. While the rope and wedge system was standard during the French Revolution, guillotine mechanisms varied across time and location. After 1800, when executions became less frequent and moved behind prison walls, some guillotines were modified with trigger mechanisms that did use levers or even early spring-loaded releases. In the German states that adopted the guillotine in the 19th century, engineers sometimes replaced the wooden wedge with a metal pin that could be withdrawn by turning a wheel mechanism. This was considered more modern and reduced the visible role of the executioner even further. The wheel was often positioned at ground level, and the executioner could release the blade while standing almost completely out of sight. The French colonies used guillotines with slight modifications for tropical climates. The wooden components were more prone to swelling and humidity, which could affect how smoothly the wedge slid. Some colonial guillotines used metal guides for the wedge path to ensure consistent operation. During the Nazi period, when guillotines were used extensively in German prisons, the mechanism was sometimes electrified. A button replaced the rope, sending a signal that triggered a solenoid to withdraw the wedge. This made the execution even more bureaucratic. The executioner pressed a button like turning on a light. Interestingly, the last guillotine used in France, which remained in service until 1977, still used a rope-based mechanism very similar to the original 1792 design. Despite nearly 2 centuries of technological advancement, authorities found no compelling reason to change what worked. The simplicity was the strength. In some early 19th century Italian states, guillotine-style machines used a completely different release system. The blade hung from a rope that passed over a pulley, and cutting the rope with an axe released it. This was actually less reliable and was quickly abandoned in favor of the French wedge system. Let's get specific about the components. The wedge, or decklick, was typically made from hardwood like oak or beech, measuring roughly 25 centimeters long, 5 centimeters wide at the thick end, and tapering to about 2 centimeters at the narrow end. It passed through a rectangular slot in the mouton that was slightly larger than the wedge's dimensions, allowing for smooth movement. The rope was usually hemp, about 1 centimeter in diameter, strong enough to handle the pull, but thin enough to move freely through the pulley system. The pulley itself was mounted on the inside face of one of the uprights, positioned so the rope ran down along the frame where it was less visible to the crowd. At the top of the guillotine, where the mouton rested in its raised position, there were often 2 small metal guides or brackets that helped align the wedge properly during the reset process. After an execution, the executioner and his assistants would use a rope attached to the mouton to pull it back up to the top. The wedge would then be reinserted, and the system was ready for the next use. The insertion of the wedge required some skill. It had to be pushed in far enough to lock securely, but not so far that it became difficult to extract. Experienced executioners could gauge this by feel. Some guillotines had a small mark or notch on the wedge indicating the proper insertion depth. The release rope typically had a loop or handle at the end for the executioner to grip. In later models, this might be a wooden crossbar, like a T-handle, making it impossible to accidentally pull the rope while moving around the scaffold. The entire mechanism, from wedge to rope to pulley, was designed to require minimal maintenance. Oil the pulley occasionally, replace the rope when it showed wear, and check the wedge for cracks. That was essentially it. So, how did the secret mechanism work? A tapered wooden wedge passed through the mouton, holding it in place. A rope attached to the wedge ran through a pulley system to the executioner's position. When he pulled the rope, the wedge slid out smoothly, releasing the blade. Simple, reliable, and terrifyingly efficient. But this wasn't just about how to make a blade fall. It was about how to transform killing into a process, how to remove the executioner's personal involvement, and how to make death appear to be a rational, administrative act rather than a violent human choice. The mechanism's hidden nature served the state's purposes perfectly. By concealing the trigger, authorities made the execution seem automatic, inevitable, almost natural. The executioner became an operator, not a killer. The machine became the actor, and death became a matter of procedure. This reveals something essential about how revolutionary France and later nations that adopted the guillotine thought about punishment and power. They wanted death to be equal, yes, but they also wanted it to be clean, efficient, and removed from personal agency. The mechanism wasn't just a technical solution, it was an ideological statement. Every detail mattered. The wedge had to slide smoothly, so there was no delay between decision and death. The rope had to be long enough to give the executioner distance, but not so long that it created slack. The pulley had to be positioned to hide the rope from the crowd's direct view. All of this worked together to create a system where death appeared to happen by itself, as if the machine, not the state, was responsible. The guillotine's mechanism shows us how societies engineer not just tools, but rituals, how they try to make violence appear rational, and how even the smallest technical details can carry profound political meaning. Understanding the guillotine's release mechanism forces us to confront an uncomfortable truth. Efficient killing requires careful design. The revolutionary engineers who created this system weren't monsters. They were solving real problems, inconsistent executions, suffering caused by unskilled executioners, and the appearance of arbitrary violence. But in making death mechanical, they also made it easier. Easier to order, easier to carry out, easier to witness, and easier to repeat. The simplicity of pulling a rope removed the physical and emotional weight that came with swinging an axe or tying a noose. This made mass executions possible during the Terror, when thousands died in a matter of months. The mechanism's legacy extends beyond the guillotine itself. Modern execution methods, from lethal injection to gas chambers, share the same design philosophy: distance the executioner from the act, make the process as clinical as possible, and hide the moment of death behind technological complexity. The guillotine's hidden trigger was perhaps the first step in this direction. There's something deeply revealing about the fact that the mechanism remained essentially unchanged for nearly 200 years. Despite massive technological advances, authorities found that the simple rope and wedge system was still the most reliable, the most foolproof, and perhaps the most psychologically acceptable way to trigger the machine. Sometimes, the oldest solutions prove the most durable. The next time you see an illustration or film depiction of a guillotine, look for the rope. Notice how the executioner stands and think about that hidden wedge at the top. It's a small detail, easily overlooked, but it was the crucial component that turned an idea into reality, a design into a device, and a revolutionary ideal into a very concrete form of death. The mechanism worked exactly as intended. That's what should trouble us most. Thank you for watching. If you found this historical deep dive interesting, consider liking and subscribing. Let me know in the comments what other obscure historical mechanisms you'd like explained. Until next time.